Hi there everyone, it's Mrs. Ortiz here and we are working on Unit 4, Objective 2. So we're going to talk about isosceles triangles and then we're also going to talk about congruent figures. And they're not terribly related, but we needed to kind of review and do a few specific things with congruent figures before we can move on to the next lesson. So if you remember from section 4.1, an isosceles triangle is a triangle with exactly two congruent sides. So a triangle with exactly two congruent sides. Okay, and so we're going to dig into a couple of relationships that happen when triangles are isosceles. And that's exactly what our essential question is today. What are the relationships between angles and sides of isosceles triangles? Okay, so before we get into this, let's make sure that we know all of the parts of an isosceles triangle. So we're going to label them. So our two congruent sides are called legs. Okay, and then the non-congruent side is called the base. And the two angles that the base are a part of are called base angles. Okay, and this point up here, okay, where the two legs intersect is called the vertex. And we could call this the vertex angle also. Okay, so there are the parts of our isosceles triangle, and those are going to be pretty important for understanding what these theorems say about isosceles triangles. Okay, so the first one is called the base angles theorem. And it says if two sides of a triangle are congruent, then the angles opposite them are congruent. Okay. So remember it says if segment AB is congruent to segment AC, then the angles opposite them. So angle C is going to be opposite of side AB, and angle B is going to be opposite of leg AC. Okay, and those two angles are going to be congruent. So we can say if segment AB is congruent to segment AC in triangle ABC, then angle B is congruent to angle C. And that's appropriate notation for that. Okay. So then if we look at the reverse of this, which says if we know that base angles are congruent, then their sides are also congruent, and that's the converse. So if two angles of a triangle are congruent, then the sides opposite them are congruent. And if that's the case, then the triangle is isosceles. Okay, so we're going to take a look at this picture. So if angle B is congruent to angle C, then segment AB is congruent to segment AC. All right, so if angle B is congruent to angle C in triangle ABC, then segment AB is congruent to segment AC. All right, so that is the base angles theorem and the converse of the base angles theorem. If you have two congruent sides in a triangle, then you also have two congruent angles and vice versa. Okay, so what we're going to do next is we're going to extend that to a corollary. So a corollary is just an extension of a theorem in a more specific situation, okay? So the corollary says if the triangle is equilateral, then it is equiangular. So now we're saying if instead of just two congruent sides, if we have three congruent sides, then we know that we would also have three congruent angles. Okay, so if we have three congruent sides, then we know that we have three congruent angles. And more specifically, if all three angles are congruent and they add up to 180, then each angle measures 60 degrees. Okay, so that is the corollary to the base angles theorem. So it's just a more specific triangle. It has 3 congruent sides instead of 2. So it has 3 congruent angles. So we can say here, if segment AB is congruent to segment BC, is congruent to segment AC, then angle A is congruent to angle B, is congruent to angle C. Okay, and then the converse is just going to turn that around. So the converse is going to say if a triangle is equiangular, if it has 3 congruent angles, then it is also equilateral. So here we're going to say if angle A is congruent to angle B, is congruent to angle C, then AB is congruent to BC, is congruent to AC. Okay. All right, so let's look at a couple of these examples and then I'll let you do some of them yourself. Okay, so in number 1, if AE is congruent to segment CE, okay, so if this triangle is isosceles right here, then angle blank is congruent to angle blank. So the base angles are opposite the legs. So it's these 2 guys right here. Okay, and we can name those as angle DAE is congruent to angle DEA. And be sure that you use 3 letters for naming those angles because there's at least 3 angles with the vertex A and even more with a vertex of E. Okay, so to be sure that we know which ones we are referring to, we're going to use 3 letters because those vertices are not isolated. All right, let's see here. You're going to do number 2. And we can take a look at number 3. And it says if angle, let's erase what we've got over here. If angle BDF is congruent to angle DBF, is congruent to angle BFD. Okay, so if we have 3 congruent angles, then we know we have 3 congruent sides. Then segment BD is congruent to segment BF, is congruent to segment DF. And I'm going to let you do number 4 as well. All right, number 5, I think you can probably handle that one. And number 6, I will work out with you. So in number 6, we notice that our triangle is isosceles because we've got these 2 congruent sides right here. So if that's true, their opposite angles, the base angles, are also congruent. And we can write the equation x squared plus x squared equals 5x plus 14. And this is a quadratic, so to solve a quadratic, we're going to set it equal to 0. So move over your 5x and your 14. And then we're going to factor this. We're looking for 2 factors that multiply to negative 14 and add to negative 5. So it would be negative 7 and a positive 2. And remember, this is still equal to 0. So we're going to set each of these equal to 0. And we're going to solve. So we're going to add 7. So x is equal to a positive 7. Or subtract 2, x is equal to a negative 2. And then we need to check to see if there are any extraneous solutions. So if we plug in a 7, we get 49 here, and 5 times 7 is 35, plus 14 is 49 here. So that checks. If we plug in a negative 2, we get a 4 here, so that's fine. 4 degrees is fine. And then 5 times negative 2 is negative 10, and we get 4 degrees here as well. Okay, so both of those are possible solutions. Okay, so we're going to pretty much switch gears here and talk about congruent figures. And it's been a while since we talked about congruent figures. This was one of the definitions we had in our very first unit. So just to review, two figures are congruent if and only if they have the same shape and size. So when we look at congruent figures, remember that we could take this triangle ABC and we could map it or move it or translate it and rotate it to be right on top of this triangle LMN. Okay, when we do that, we end up with corresponding parts. All right. So when we look at this list right here, it says congruent figures have congruent corresponding sides. Okay, so if we were looking at corresponding sides here, that means that this side BC, because it has one mark, corresponds to this side MN because it has one mark. So BC is congruent to MN, okay? And then AB, because it has two marks right here, it corresponds to the side with two marks over here, so that would be LM. And now you're getting the idea, so AC is going to correspond to LN, okay? Now, when we have two congruent figures, they get the same size from having congruent sides. So size and sides go together, okay? Congruent figures also have the same shape, and that comes from the angles. So they have congruent corresponding angles. So if we look here, angle A is congruent to angle L. Angle B, okay, is congruent to angle M. And angle C is congruent to angle N. And those are corresponding angles giving us the same shape. Okay. When we look at two triangles that are congruent, we can write a congruence statement. And so what's really important in this congruence statement is that you do it in the correct order. So I'm going to start with triangle ABC. And we're going to say that this triangle is congruent to triangle LMN. And what's important about the order is that you have corresponding angles in the same order. So A corresponded to L, and B corresponded to M, and C corresponds to N. Okay, so this is called a congruent statement. And all I did was I looked at this list of angles and then followed the same order for the second triangle. Okay, and then like I said about the mapping or being able to move one triangle on top of the other so that they're the same, to see that they're the same size and shape, those are actually called rigid motions. Okay, and they map one figure onto another, either through a series of movements called translations, rotations, or reflections. And all that means is we're going to take this triangle ABC and we're going to slide it over and rotate it or reflect it so that it sits exactly on the other triangle. Okay, so those are called rigid motions. All right. So in number 7, it says if triangle MNP is congruent to triangle XYZ, then angle N is congruent to, okay, so we're going to use the congruency statement, which is why the order is so important on the congruency statement. So angle N is congruent to angle Y. Segment NP, the last two, are congruent to the segment YZ, also the last two. And angle PNM, moving backwards, right, is going to be congruent to, we're going to start here and move backwards also, to angle ZYX. Okay, so using the congruency statement, we know exactly what corresponds and what's congruent to each other. All right, So I'm going to let you do number 8. It says name all congruent parts and write a congruent statement. So remember, all congruent parts includes angles and sides. And because these are quadrilaterals, you should have a list of 4 congruent angle pairs, 4 congruent pairs of sides, and then a congruent statement. Okay, now you've learned that a congruent statement for triangles is triangle ABC is congruent to triangle XYZ, for example. Okay, when we have polygons that have more than 3 vertices, all you do is pick a polygon and pick a vertex. So I'm going to start with U. And you just move around it either direction. So we call this UTSV. All right, or maybe you could start with TSVU. Okay, but you pick one vertex and you go around it. And then when you do the congruency statement, you'll say that it's congruent to, and then you'll fill in these blanks. Okay. Notice that there's no symbol in front of those 4 points. Okay. All right. The reason that there's a triangle here, by the way, is because if we were to just say ABC, that would be the name of a plane. Okay, the last example we have here is number 9, and it says use the given congruent statements to correctly label the diagram. So the first one says that angle BCD, so BCD, so this whole angle here is going to be congruent to angle CBA, so this whole angle here. Okay, the second one is a little bit unusual. It says BC is congruent to BC, and so BC is only on here once, but it's used twice. Okay, or maybe 3 times. So it's used on triangle ABC and triangle DCB. So we can mark something congruent to itself. Okay, and then I'm going to let you go ahead and do C and D on your own. Okay, so real quick, let's go back and answer the essential question, and then that will wrap up this lesson. So what are the relationships between angles and sides of isosceles triangles? So we learned that if there are 2 congruent sides in a triangle, then the opposite angles are also congruent. And then we also talked about the converse. Okay, that wraps up our lesson. Have a great day. Bye.